So in this video, we are looking at two graphs that have asymptotes. Now, remembering this word asymptote, that means that there's a particular part of the graph where the function will get very, very, very close to the line, but it will never touch it. And we'll be able to show this visually in these two examples. Now, the first function I have here is what we call an exponential function, which we have seen previously on this channel. So I'll go through it relatively quickly. Now, I've substituted in these already. You can pause the video just to substitute these x values into the rule here and just verify the numbers that I have. But these exponential functions have the input x as being the power. So as we change that base number, it will end up changing the steepness of the graph, how quickly it goes up. Because when something increases exponentially, it means quicker and quicker. So just to give a simple definition. So we're going to go straight ahead and graph this in. We're going to plot the points. So when x is -3, y is +1/8. So it's really, really close to this x-axis already. When x is -2, y is 1/4. So that's about here. When x is -1, y is 1/2. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is 8. So you can already get a feel for how this graph is going to look. Now, joining up the dots, we're going to try to draw a smooth, continuous curve that passes through all of these points. And you can see that over here on the left, it appears as though it's getting closer and closer and closer to the x-axis. And on this side, it's going up quicker and quicker and quicker with each one step in x. Now, this is the graph of our exponential function y equals 2 to the power of x. So just a note on the asymptote, we can see that our asymptote is at the line y equals to 0, or the x-axis. So if you imagine this line, y equals 0, which I'll do dotted in red, the graph gets closer and closer and closer to this line y equals 0 as x approaches -infinity. So as x gets smaller in the negative direction. So we're actually just going to make a note of that. As x approaches -infinity, the y approaches 0. This is just a note we're going to make to help us to basically understand the exponential function and understand the asymptotes as well. Now, the next one is the reciprocal function or the hyperbola. We've also talked about this one previously. So I've already written in a few values and substituted into the rule. You can once again pause the video and check. Now, you may notice I've put an asterisk for when x equals 0. This means that the function is undefined at this particular point. And we can pretty clearly see why. If you substitute a 0 in there, you can't divide by 0. So if you put this in your calculator, it will show up as math error. Now that we have these points written in, I'm just going to substitute them in. So when x equals to -5, y equals to -1/5. So that's going to be about here. When x equals -2, y is equal to -1/2. When x equals -1, y is -1. When x is -1/2, y is -2. And when x is -1/5, y is -5. And we notice that there's no point when x equals 0. So this whole section here is going to be undefined. We'll see how this looks in just a moment. Now, moving on, we're going to look at the positive x values here. So when x is 1/5, y equals to 5. So 1, 2, 3, 4, 5. That's going to be about here. When x equals 1/2, y equals to 2. When x equals to 1, y equals to 1. When x equals 2, y equals to 1/2. And when x equals 5, y equals to 1/5. So we can see what this graph looks like. We can get a bit of an idea of it. So just connecting the dots, I'm going to try to draw a continuous curve that passes through each of these points. I get this part in this quadrant, and then here, I'm going to get a similar thing happening. And I get this over here. Now we can see that the graph is in this quadrant and this quadrant, and we can see a pretty clear asymptote. So not just one, we can actually see two lines that this graph will approach and get really close to, but never actually touch. One is this one over here, if I draw it with a dotted line. So this is the asymptote of the line x equals 0. And also here, we have y equals to 0 also. So we basically have two asymptotes here, and I'm actually going to make a note of what is happening with both of these. So we notice that as x approaches positive infinity, so as x gets bigger and bigger and bigger and bigger, y approaches to 0. That's what I'm drawing with this arrow. By this arrow, I just mean approaches. And also, as x approaches negative infinity, so as x gets smaller and smaller and smaller, the y will approach 0 also. Now, a couple of other ones that we notice. As x approaches 0 from the positive direction, or in this kind of positive value of x, as x approaches 0 from the positive direction, y approaches positive infinity. So the smaller and smaller this x gets, closer to 0, y will get closer and closer to infinity. Y will approach infinity. So we're imagining, remember, like really small, like tiny values of x. So I'm going to say, as x approaches 0 from the positive direction, that's why I've written this little plus here, y approaches infinity. And also, as x approaches 0 from the negative direction, so if we look here, the x value is approaching 0 from the negative direction, and y is getting closer and closer and closer to negative infinity. So we can write y approaches negative infinity. So this is how we can understand our asymptotes and how we can understand how they behave in the context of our reciprocal and exponential functions. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.